Next hands-on is developing a time series prediction model. Below is a step-by-step guide for developing a time series prediction model using TensorFlow. Step 1 is data collection and preparation. First, for that, you do data selection, where you choose a time series dataset suitable for prediction task. Examples include financial data, weather data, stock prices, etc. Next is data processing. Pre-process the time series data by handling missing values, scaling the data, and splitting it into training and testing sets. Step 2 is building the recurrent neural network model, RNN. Model architecture. So design an RNN architecture suitable for time series prediction tasks. Common choices include long short-term memory, LSTM, and Gated Recurrent Unit, GRU networks. Model definition. Define the RNN model using TensorFlow Keras API. Specify the number of LSTM or GRU layers, hidden units, activation functions, etc. Step 3 is model training. So first you do data preparation. Prepare the time series data in sequence or windows suitable for training the RNN model. Use techniques like sliding windows or time series generators. Next, compile the model. Compile the RNN model by specifying the loss function, optimizer, and evaluation metrics. Next, do the training. Train the RNN model on the training dataset using TensorFlow's fit function. Monitor training progress using callbacks like model checkpoint and early stopping. Next step is model evaluation. First, validation. Evaluate the trained model's performance on the validation dataset using metrics like mean squared error, MSE, mean absolute error, MAE, etc. Next, to fine-tuning. Fine-tuning the model architecture and hyperparameters based on validation performance to optimize model performance. Next step is model deployment. Save the model, save the trained model, weights and architecture using TensorFlow's save function for future use. Next, to deployment. Deploy the time series prediction model using a suitable deployment strategy, such as deploying as a REST API using TensorFlow serving or Flask. Step 6 is continuous improvement. Monitoring and maintenance. Monitor the deployed model's performance in real-world scenarios and update it periodically with new data or fine-tuning to maintain accuracy and adapt to examples. Here is a code sample of how to do this. So first, import TensorFlow, then layers and models from TensorFlow Keras. How to build RNN model? You can call the sequential function and pass the layers function of LSTM, pass the parameters, then call the dense layers and pass the parameters. Next, you do model training by calling the compile function first, then fit, and then do the model evaluation. While doing model evaluation, you can call the evaluate function and pass the values of x test and y test to it, which will give you the test loss. Here you can print just to see the loss evaluation here. Next, do the model deployment. First, save it, and then you can deploy it using the Terraform serving or Flask. And once this model runs, you can do the continuous improvement as and when you monitor the performance, fine-tune the model, update with new data periodically. This example demonstrates how to develop a time series prediction model using TensorFlow's Keras API. You can customize the model architecture, pre-processing techniques, and deployment strategy based on your specific requirements and dataset characteristics. Additionally, consider exploring advanced techniques like attention mechanisms and ensembling methods to further improve model performance.